Good morning, good afternoon, good evening, wherever you are. Welcome to the first Excelero CMA webinar. My name is Tom Layden. I'll be your host tonight, which means that I won't have to do a lot of talking, fortunately, as I have two excellent speakers for you today. I have Brian Doherty, Chief Technical Architect from CMA, and Josh Golden, our Vice President of Product Management at Excelero. Brian, why don't you start with a quick intro on CMA and yourself?
Thanks, Tom. As Tom mentioned, my name is Brian Doherty. I'm Chief Technical Architect at CMA, responsible for all the high-end technical delivery, blueprints, and products in our database and infrastructure. CMA is a large-scale systems integrator with offices throughout the country, specializing in delivery of large-scale analytics for healthcare companies, government companies, and other financial services companies. We also have a products division. In that products division, we essentially build products that we can't find on the market, products that we need to support our high-end clients.
All right, thank you, Brian. Josh, can you give a quick intro about Excelero and yourself?
Sure. Well, I'm Josh Goldenhar, the VP of Products for Excelero. Excelero is a little bit over a 3-year-old company, and we specialize in providing software-defined storage specifically for NVMe. So it basically lets you create a SAN or a server SAN that is using standard servers off the shelf, NVMe drives, to make basically some of the world's highest performing, lowest latency, highest bandwidth storage.
All right, thank you. So today we're going to talk about how CMA engaged with Excelero to integrate their Microterabyte Oracle RAC solution with Excelero's NVMesh software-defined storage. First, Brian will tell you all why and how they built that solution, and he will also talk a little bit about the performance results, which are awesome. And then Josh will show you what's under the hood. For your information, the chat channel is open for question. We will be answering the questions during the session, but the more intriguing questions we will save until the end so all attendees can benefit from the answers. So, Brian, why don't you kick it off?
Great, thanks, Tom. So, the agenda, let's go through the agenda. First, we'll talk brief intro. We'll talk a little about what we see as the next generation database requirements, kind of what's driving the need for this type of technology and the growth in the industry. We're going to talk a little about Data Warehouse in a Box, our Microterabyte solution, and why we think that has a value to a lot of customers. That's been out for 11 years now, and we're excited about this latest version release that we have of the product that'll exploit the Excelero technology and NVMe technology. We'll speak a little bit about the value prop that we're bringing to the table for the array of customers that we service, especially the high-end and more complex environments. And finally, we'll end up with some performance numbers that we'll talk a little about, some performance comparison against more traditional solutions and our Excelero-based Microterabyte NVMe. And at that point, I'll hand it back to Tom, and Josh will go a little bit deeper into under the hood, the Excelero technology, and give you a lot of great information on some of the detail of the software solution. And then we'll have a Q&A. So I wanted to start by talking about this Oracle RAC Performance and our Microterabyte solution and how we got to that and what some of the value prop that we see in this solution and product, and kind of why we're going down this path at this point. So what is the Microterabyte with the Excelero, the NVMe? Quite simply, it's a high-performance, pre-installed, pre-configured Oracle 12C rack cluster in a box. So we take away all the complexity, we take away the margin of error in building and developing an Oracle 12C rack cluster, which is a challenge for a lot of companies. It's a repeatable, fungible solution that's modular. You can start small, start quick, and then you can, in a very elastic manner, expand that and grow as you need to. It's rack stacked, wired, ready to ship and plug into a data center. So we've pre-calibrated, pre-tested different configurations, and that's ready to ship out to you. So you really need to just focus on creating your particular applications or your particular database on top of this platform that's ready to go. It's pre-calibrated and there's scalable configurations. So as I said before, we start small and we can grow quickly. So that allows you to reduce your investment up front, get all the value out of, quite frankly, a starter configuration, and then grow and expand that very, very quickly if you need to. What are some of the challenges that we're seeing and we think a lot of companies are seeing in the industry relative to this area? Well, speed and productivity. We don't have 2 to 3 months to try to build an Oracle RAC solution, experiment with it, and then find out it doesn't work, or that it's not calibrated properly or it won't scale. So this solution that we've put together now with the Excelero technology can be delivered very, very quickly. So you're not spending 3-4 months trying to design, test, and configure the solution. You can get it to market very, very quickly. Anything as a service, there's increased demand to drive value and productivity out of a small footprint cluster, an Oracle 12c database cluster. There's many databases that are being spun up dynamically. There's an insatiable demand to really just exploit the platforms that are built and to drive additional database performance and productivity very quickly. Public, private, and hybrid. So, the other thing we're seeing is that a lot of activity between certainly still on-prem and private database solutions, but also the ability to deploy either hybrid or in a cloud environment, database solutions that can be spun up very, very quickly. Budgets are tight, so we really don't have, a lot of companies don't have money to go out and to build a particular rack cluster for each application. They really want to build a core infrastructure and then layer databases and projects on top of that core infrastructure and exploit that infrastructure investment and then expand on that investment. And then the optimization. There's an ever-increasing demand for additional data. We have clusters and databases now that are in hundreds of terabytes. We have over petabytes of storage for database clusters that we have that we're supporting databases. So the optimization of that cluster is crucial because no one wants to use a database that takes forever to get an answer, or when you have terabyte tables for large-scale analytics that take hours to do the analysis. So people really need a platform that can deliver performance at reduced latency so they can iteratively work through their business problems and continue to exploit the investment that they've made. So when we started out first working with Excelero, we kind of put together some design goals. What did we want to get out of the solution that we were building and what were we searching for? So we boiled these down into 7 design goals that were driving what we're doing. First of all, we wanted software licensing, especially with the Oracle RAC cluster, Oracle software is always an issue. It becomes very expensive, as you all know, to keep throwing hardware at a solution and additional core counts because you can't get the performance that you want. So one of the things we wanted to do was see if we could shrink that Oracle software licensing and just actually not only Oracle, but all software licensing costs, the more powerful, denser solution. In the past, really what people would do a lot of times is you may see an Oracle RAC cluster that was 4, 6, or 8 nodes. And the reason it was 8 nodes isn't really because of a CPU or a kind of a processor issue. It was really 8 nodes because people could only service so much I/O into a database node. If you can deliver 4 to 6 gigabytes into a database node, and you've got 24 gigabytes sustainable you need across the cluster, then you need 6 or 8 nodes to be able to do that. But if you can deliver 20 gigabytes per node coming into a RAC node, then you can get away with fewer nodes. You get away with fewer nodes, you get away with fewer Oracle RAC licensing costs. So it's a great way to reduce that software licensing. We wanted to enhance that database user experience. We wanted the user to have predictable, high-performance response time. So if you look at both of those things, the performance, but you also look at predictability, we think that predictability is more important even than performance. If you get high performance on one query, but you have very long performance on another query because you have inherent architectural design that leverages and expects certain query plans. That's not a good thing. But we feel with the Excelero software, with our ability to drive so much I/O per node, we have a simple, lightweight, and a very predictable platform that's also very high performing. We wanted to make sure that we could, for very large databases, one of the big problems is very large maintenance operations. Backups, index builds, materialized view builds, they can take hours and hours. So we needed a platform where we could really shrink the time to create these derivative structures and to get these database operations done, and we've done that. We wanted to provide flexibility for changing workloads and increased workloads. We want the ability to be able to drop additional databases on existing platforms. And this platform gives us some excess scalability where we can actually adapt to a spike in a workload or a spike in database growth. Productivity is always something that's important to us. If you've got a business user that's running a query and it takes them, 3 hours to get an answer to the query, but they just missed the query, has the wrong answer by one column, now they need to run that query again and it takes them 2 more hours. That's a big problem. So what we wanted to do was provide a platform that responds in seconds and minutes, allows them to iterate quickly and drive up the productivity on the business side also. Reducing the hardware and software total cost of ownership, big thing for us. So one of the things we wanted to do was reduce the power, the form factor, and the licensing costs. Really all of those things moving in that direction and latency while we continue to increase the bandwidth, and we think we've accomplished that. And finally, we wanted to be able to the ability to scale up as we grow and we add more companies and we add more companies' databases, which is a crucial thing, and not have to kind of reinvent the infrastructure that we built out. So a little bit more about this Microterabyte. Again, the idea is ultra high performance, very elegant, simple, quick deployment, and pre-calibrated. So here's a starter Microterabyte NVMe leveraging the Excelero technology. We'll just give you a little bit of introduction to this. In this starter kit, starter Microterabyte NVMe, we have 3 rack nodes, 3 Oracle RAC nodes that are TU RAC nodes. Those are Dell Intel RAC nodes that we have there. The interconnect is supported by Mellanox IS5030 QDR switches. So our interconnect is running through 2 1U Mellanox switches. Our I/O is running through the Mellanox SN2700 switches, and all the I/O is flowing through those SN27 switches down into 4 storage nodes, the Dell 740 XD storage nodes that are there. So the total solution itself is less than a 42U rack, half of a 42U rack, but yet it gives us the power that's double and triple of previous solutions that we had that were 6 and 8 cabinets of floor space. So it's ultra high performance, ultra small form factor, really simple implementation, and very powerful and ultra low latency. The rack nodes run Red Hat 7.3 with the Mellanox OFED drivers and the Excelero NVMesh client software, which Josh will talk more about. And in this configuration, we have delivering NVMe drives, 10 NVMe drives, 1.6 terabyte NVMe drives in each of the 4 storage nodes. They're evenly calibrated and they're redundantly wired and zoned into the Mellanox 2700 switches running 100 gigabit Ethernet. So in the rack nodes themselves, for the I/O, we're using Mellanox ConnectX 5 switches, dual port 100 gigabit per second Ethernet. So in this RACI solution, for this Microterabyte NVMe, in those 3 rack nodes, we have driven a sustainable 60 gigabytes per second of sustainable I/O in this configuration, which is an enormous amount of bandwidth in a 20U form factor to deliver up into a rack cluster. So again, this is the kind of the starting point for a building block. You can expand on this both on the rack nodes and also on the storage nodes, but this is a calibrated configuration that delivers great latency, great bandwidth, and is ready to expand. I should say on the back end, the storage nodes, we have the Excelero NVMesh target software and the NVMesh management software. So the complete solution, again, is a very, very simple yet elegant solution to deliver. So what's the value prop for the customers in this solution? Well, we think, as it was mentioned before, the performance is an outstanding performance, and the latency, which is crucial for a lot of the work that we do, is very important also. I mean, high bandwidth is one thing, but high bandwidth at high latency is not a good thing. On the prior platforms that we're running, we're seeing bandwidth that's half, we'll talk a little about this, half the bandwidth that we have here. But the more important thing is we're seeing latency that's in the 5 to 10 millisecond on very large, heavily hit platforms with large block I/O. So we really wanted to get latency that's under that millisecond, way under that millisecond response time for 128 kilobit or a megabyte I/O that's being sent down through, and we're certainly getting that here. So high performance, very low latency, simple yet elegant. It's really simple, really to deploy, and it's also very kind of transparent in terms of being able to look at it. There's not a lot of on the Oracle side, on the Linux side, there's not a lot of software, there's not a lot of configuration, and there's not a lot of additional software that makes it a very complex solution to build. It's a very lightweight solution, and that makes it kind of expand very easily also. The deployment's very rapid. Again, if you buy the Microterabyte, you plug it in. If you don't buy the Microterabyte and you were to go out and we were just to try to implement this separately, that's also very, very quick and very rapid deployment. But since the solution has kind of fewer software layers, and it's a very open solution that kind of wraps around commodity components that are there, it can be rapidly deployed. And finally, elastic scale-out. It's very easy to add either rack nodes or storage nodes in this configuration, in a matter of hours rather than in a matter of weeks with a lot of downtime. Some additional value props: the ultra compact form factor. We're seeing 60 gigabytes per second sustainable across only 3 rack nodes in a 20U, half of a 42 rack form factor, which is an awesome throughput for that form factor. We've taken, as I said, 6 to 8 refrigerator cabinets solution. That's about 10 to 12 times the floor space, and we've been able to reduce that into half of a 42 rack while still getting this performance. The economics of the solution was another thing that drove us to this. Again, we want dense solutions. We want fewer hardware, we want commodity hardware, and we want ultra high performance. So this is kind of the directional best case for all of this. Reduce form factor, reduce power, reduce hardware cost, reduce software cost, but increase performance. So it's a great price-performance ratio for us, and it's one that we can economically scale very easily. Anybody can throw, not anybody, a lot of people can throw all kinds of hardware at this solution, but when you try to scale that, financially it becomes into the millions and millions of dollars very, very quickly. And even then, you don't get the performance that we have here. And finally, one of the value prop we think for our customers is our ability to exploit advancements in the NVMe and the flash industry. And one of the great things about this is there's really, with the Excelero solution, is that there's no kind of proprietary hardware that has to be deployed as part of this solution. So it's very difficult to scale and evolve as easily if you've got proprietary hardware to get the performance that you're getting. But really, with this solution, we can take advantage of all the advancements the industry is making in these two areas. Where did we come from? We started on this high-end databases. We started where a lot of people are, where a lot of people started. They started on kind of Unix-based large-scale systems in this high-end with Oracle RAC clusters, with high-end monolithic, very good but very expensive and very large storage arrays. Some of the characteristics of that environment were obviously the high cost, not cheap, very costly, and the cost you pay per unit of performance is also incrementally or marginally higher than we're talking about here, much higher. It's a massive data center footprint. You all know that there's just cabinets and cabinets of storage and components that are there, high operating costs, and we got good performance. I would say moderate to good performance, but it's very expensive, very high footprint. From a planning standpoint, kind of a larger planning horizon, you really had to think about how you wired and created that Oracle RAC cluster. Then we moved down a couple years ago. We started looking at some alternatives. We moved off that AIX base down into the Red Hat Linux environment, and we started to work with what we'll call the first generation NVMe technology, with a technology from a company called DSSD. So that provided some value to us. We got a performance boost. It came with a cost. It was costly, and the controllers and the hardware. There's a proprietary hardware component, so it made it a little bit more expensive. It made it harder to scale in an elastic manner. So it was definitely a step in the right direction from performance, but we still had some limitations in our ability to scale this in a fluid way, and it was still costly. And the form factor was a higher form factor. So a couple of years ago, we started looking, and we settled ultimately on what we think is the place to be at this point within the industry and where the future is going to be. And we worked on and started to develop our Microterabyte NVMe with RACI RDMA over Converged Ethernet version 2, and the Excelero, which was the best solution in the industry. And we looked at several options. We get ultra high bandwidth with this solution, with very low latency. The form factor, as I mentioned before, is a very, very tight form factor, simple to deploy, and very simple to scale out. If you know, on the Oracle side, in terms of the deployment itself, there's no ASM live. The storage setup is very easy. You create the volumes, present the volumes up into the rack nodes that are there. You see them as in cat-proc partitions, so you see them presented through the partitions, and you create the ASM disk groups. You don't need ASM live, and you're ready to go. It's a very, very, very simple to deploy and a very, very simple solution. So in terms of the extra work, let's say outside of the norm of the Oracle, it's not existent. Very, very simple. And finally, some benchmarks. So what do the numbers look like? So we've done several benchmarks off and on-prem. This is one of our on-prem benchmarks. So what we did is we run it through a set of internal benchmarks that we think, having been in this business for a long time, supporting very large databases and thousands of customers for analytics on these are some, on the left-hand side under the benchmark, these are some of the seminal operations that we think, if you can't, this really will drive and dictate the performance of the solution. On the one left column, we have EMC 400K. That's running this benchmark against an Oracle 8-node rack cluster. This is new hardware, 8-node rack cluster, and a 4-engine, it's called a 4-engine EMC VMAX all-flash array. So this is an all-flash array, 4-engine, what's called a 4-engine on a kind of a high-end, state-of-the-art storage array. And on the right, we have the Excelero and the configuration that we showed before, only 3 rack nodes. So you notice we go from 8 nodes on the rack side to 3 nodes. And one of the reasons we can do that is because, again, we can drive 20 gigabytes per second up into that, plus 22 gigabytes per second up into each rack node with the Excelero solution. We can only drive about 6 to 8 at max, 6 on the left-hand side of the EMC solution. So that in itself is a huge, so the bandwidth per node is a crucial metric, and it's a great metric in terms of predicting how much you can save on the Oracle licensing also. So on the right-hand side, we have that 3-node rack cluster of the 4 Dell 740XDs. So the creation of 10 terabyte table space with a 100 terabyte database, you have to be able to create table spaces. On the EMC, it was 111 minutes, as you can see, only 34 minutes on the Excelero. So to create 10 terabytes, 34 minutes, which is a great time, and means that if you have to drop tables, create a materialized view, or for some reason get a very large table space, you can do that very, very quickly with Excelero. And this is one node, I should say. When we run this, 3 of these, this is a serial operation in Oracle, across all 3 nodes, you would see that scale linearly, and we've tested that also. So you could potentially get in across 3 nodes in that 30 minutes, 30 terabytes of table space created if you wanted to. The other thing we do is a parallel direct path insert, 8 billion rows. We use an 8 billion row table in this. This is to get it out of one table in this Oracle RAC cluster and get it into another using that direct path insert in the parallel mode. 156 minutes and 83 minutes on the Excelero. Again, both really good times. That's 8 billion rows, and this is a table that's about 12 terabytes. 10 terabytes fully loaded for us right now. It's about 12 terabytes, but in this benchmark it was 10 terabytes. So 10 terabytes of rows being inserted into one table in 83 minutes, a little bit over an hour for the Excelero. Created a unique global partition index to create, and the bitmap index. You can see that phenomenal time, 6 minutes versus 11, and 21 minutes versus 92 minutes on that bitmap. But 6 minutes to create a global partition index on that 8 billion row table, which is a phenomenal time. Finally, down on the query side, just a single query scan time took 27 minutes on that 8 node. And that's using all 8 nodes in that 400K, and took 3 minutes on the Excelero. So 3 minutes to scan that table, again, gives you much more flexibility in everything you do in terms of supporting queries, indexing, because the indexing is really a function of that base query scan time also. And the maximal sustainable rate, 8 gigabytes per second on the 8 node 400K, and 22.68 gigabytes sustainable on the Excelero with the Microterabyte NVMe. So again, I can't stress how much value and how much flexibility that gives you if you can drive over 20 gigabytes per second into a single rack node. And then finally, the aggregate sustainable of 30 gigabytes per second on this EMC 4 engine, and 60 gigabytes per second on the Excelero. A final thing I should mention, that the 400K and the 8 node solution is a multi-million-dollar solution, and the Excelero solution is a low hundreds K solution. So when you look at the price performance of this, not only is the performance outstanding and the form factor and the power, but the investment and the cost is significantly lower on the Excelero side, significantly lower. And that's, I'll pass it now back over to Tom and Josh.
All right, thank you so much, Brian. And while I'm switching the presentation over to Josh, that was really interesting. I think those numbers speak for themselves. So I'm getting in some interesting questions. I'll save them until the end. Anyone who has more questions, feel free to put them in the chat window. In the meantime, I can see that Josh is ready to give you guys a look under the hood. Josh, take it from here.
Thanks very much, Tom. And Brian, thank you so much for that. You actually made me wonder if we're not charging you enough money, if you can save that much. I think that was about a 1/30th cost for about double the performance. So
yeah.
As product management, I'm going to have to go back and review that.
Yeah.
But you know, kind of that's what you get for being such a great customer and willing to do this kind of stuff. So first off, everyone there, thanks. We want to boast a little bit. Excelero is very proud that we just recently were notified that we won Tech Target, Storage Magazine's Software Product of the Year for software-defined storage for 2017. And this is really key because some of the people that we were competing against were very established companies. I mean, not other startups. These are folks that have been around a while and have very good products in their own right. So we're very proud to have won this article, and you can go ahead and this award, that is, and look this up yourself on Storage Magazine, Search Storage, and Tech Target. But we're very happy about that. And exactly, well, what did we win? What is Excelero NVMesh? So NVMesh stands for non-volatile mesh. It is server SAN, and server SAN was a term coined by Wikibon. So hats off to them. And what server SAN conveys is that you can replace traditional SAN functionality with off-the-shelf servers. You add software such as NVMesh, an intelligent software layer, and with that, you get software-defined storage that you can build very flexible block storage infrastructures. It acts like a SAN, it walks like a SAN, it talks like a SAN, except for the fact that it's way lower latency than traditional SANs and much higher performance. So by introducing these off-the-shelf components, new state-of-the-art technologies, 2550, 100 gigabit Ethernet, new servers, NVMe media, you put all these together and you get this very, very high performance solution that Brian was talking about in conjunction with Oracle RAC. So how does this work? Well, NVMesh is the software you put on top of Linux servers with NVMe drives, and it pools all that NVMe storage and puts it on the network, making it available at local speeds. This is hard to believe for a lot of folks, but you can access this NVMe storage via logical volumes at the same speed as if the NVMe is inside the server itself. And that's part of why it's been so effective for this low latency architecture that Brian was telling you about with CMA. It's a client-side architecture. This is what makes it distinct from almost anything out there on the market. That is the clients, in this case, from what we were talking about, the Oracle RAC nodes themselves, they have a block driver that is intelligent, and it knows how to get the I/O to and from the target storage nodes in the most efficient, lowest latency way. And this enables true convergence on the targets. Now, it's not being used in this case, but true convergence in that we do all this without using any CPU on the target systems. So by bypassing CPU on the targets, it's what Brian was mentioning, that you can get very affordable target systems for your storage because you don't have to use high-end processors. You can use processors that are much more middle of the road because they're not really doing anything to serve the storage. They're more kind of acting as an I/O bridge between NVMe and networking. So this makes the actual hardware you purchase to act as storage very, very inexpensive. And the why, I think the why should be self-evident by this point, and that is you can maximize utilization of your NVMe. You can actually make it available to multiple hosts. You get the full performance, the full benefits of NVMe by distributing that amongst multi-clients, and you get all the performance as if that NVMe is local. It's very, very scalable. As much as you've heard about some amazing performance numbers today, when that cluster grows, you can simply add additional nodes and scale your performance linearly. So it's a very, very great flexible solution. Now, I talked about this a bit. You may say, well, this all sounds, kind of different, and how does it exactly work? You can see here from the diagram on the right that it's actually very simple. You take servers. In the case of CMA, you saw that they were using Dell servers. However, we use basically any off-the-shelf common standard server. So servers with NVMe drives and RDMA NICs, that is either Ethernet or InfiniBand, but Ethernet is now very common. We run Linux on those servers. On top of that, you put the NVMesh software. And then from there, that acts as a hardware abstraction layer to offer logical volumes that you define. Logical volumes can be any size. They can be striped across multiple drives, multiple hosts, and you can define them to have different availability levels. So you can define them just to be RAID 0 stripes. You can define RAID 1 or RAID 10 mirrors or striped mirrors. And then later this year, we'll be offering additional erasure-coded offerings. And then on top of these logical block volumes, which can be shared to multiple hosts, which is key here, you put your file system or a shared parallel file system, or in the case of what Brian was talking about with CMA, that's where you have an Oracle AMS on there. So you're actually using these block devices on multiple hosts. That is, our block devices allow for multiple hosts to attach to the same block device, just like a SAN. And if you have some kind of cluster, I meant ASM, excuse me, Oracle ASM. If you have something like Oracle ASM that can go ahead and use the same block device on multiple hosts, then you can go ahead and use that. You can also use it with traditional clustered file systems, such as IBM's Spectrum Scale, formerly GPFS, and other file systems that are shared amongst the same block devices. Okay, and lastly, you go ahead and put your application on top. So in this case, we're running Oracle RAC on top of ASM, on top of the logical block devices, which goes all the way down to those servers. The components, this may sound complicated, but it's really not. NVMesh is 3 main software components. It is a block driver, which we also call the client or initiator. It's the target module, which runs on the hosts that have the NVMe drives. And we have our management interface. These can all run on one host or one group of hosts, as you saw, and we'll go ahead and review. So when you add all these things together on a high-speed network, you can have clients and targets, or individual systems can be both clients and targets. And it just looks like a regular network. However, you're sharing NVMe with protection. That is protection against host failures, protection against drive failures. You have a completely redundant solution. In the case of CMA, we're bringing this diagram back up that you saw earlier. You can see that they're getting this amazing amount of performance in only 8 rack units. That is, the storage nodes are at the bottom. Each storage node had 10 NVMe drives. This represents a total capability of about 92 gigabytes per second of read bandwidth. There are 3 Oracle RAC nodes. Each of those have about a raw 23 to 24 gigabytes per second of network bandwidth. And as Brian mentioned, they're getting over 22 and they can sustain over 20. So you can see here that they're actually a little undersubscribed for the rack nodes. That's why these rack nodes can all run at full throttle and not contend with each other for storage resources, because you actually have in this fairly limited or small setup more bandwidth than you can eat with the Oracle RAC nodes. So this is very small. Amazing that you can replace 6 to 8 cabinets of gear with half a cabinet and yet get higher levels of performance. The other thing that should be noted on this diagram, it's a completely redundant solution. It is redundant. It is multi-path with path failover. The storage is striped across all the nodes, both for balancing and for redundancy. We can lose any node. We can lose a drive from any of these cabinets. So you have complete redundancy and failover capability. So what makes us unique? We are 100% software. As Brian pointed out, this makes it extremely affordable. You pick the servers, NVMe media of your choice, and put our software on top. And this makes it extremely economical. And you have the freedom of choice for basically anything you want with no proprietary hardware lock-in. It is elastic. That is, it's an elastic NVMe solution in that it can change. You can go ahead and add nodes or drives at any time and expand pools and expand existing logical volumes. And everything scales perfectly linearly. As long as you add drives and network at the same time, we have 100% linear scalability there. Zero CPU. This is enabling, again, either more cost savings or the ability for true convergence. That is to go ahead and run applications on top of your storage because the storage is not using the CPU itself. Serving that storage is almost free, which means you can run applications on those same CPUs, and that can help you to further get efficiencies or lower costs. The whole thing works as a virtual array. It is completely distributed, and it supports both converged and disaggregated architectures. We're using a disaggregated in this sample. And lastly, I did mention that our intelligence is in the client side, and this is what enables near 100% efficiency and scaling. That is, any other solution on the market that uses traditional controllers, the controllers represent a bottleneck. That is, they may have a very high limit, but they are going to be the limit. And once you reach the limit of that controller, you have to add another entire system. This is not the case with us. We don't have any performance bottleneck. There is no centralized lock manager. We scale linearly up and to the right for as large as you can make the cluster. We do not degrade performance after you reach a certain size. So a very, very unique architecture there. Now, all this, of course, was towards Brian telling you about the story of Microterabyte and these very large Oracle databases, the efficiencies, the cost savings it's recognized. NVMesh eliminates these traditional bottlenecks, allowing you to reduce your footprint significantly, getting unlimited bandwidth essentially for your Oracle RAC nodes, which really saves you tons of money. In this instance, we saw how this cluster is performing roughly twice as fast as a cluster that was twice that size. So the reduction in Oracle licensing costs alone will more than pay for the solution. And so it's very, very good for these high performance, large scale databases. So with that, we'll move over to questions. I want to thank everybody for attending. And of course, if you want to hear more about either Excelero NVMesh or CMA, there are email addresses here that you can use for either. And then with that, I'll hand it back to Tom and we'll go to questions.
Thank you, Josh. That was very good as usual. And I'm getting very interesting questions from the audience. So you guys brace yourselves. First question I get here is whether there is support available to detect connection problems between or potential connection problems between the controller and the host or vice versa, such as watchdog timers.
So if you purchase this with the Microterabyte, we have a support. We support 7x24. We have a support. Part of the license is a support license. So we take care of making sure that all the components that are part of that Microterabyte are supported. So there's full support for that Microterabyte NVMe as delivered.
And of course, on the Excelero side, if you were just getting the Excelero NVMesh software, we also have 24-hour support in the case of phone support and email, and so you would have full live support if you had to detect some kind of issue there as well.
All right, good. And then a next question I'm getting is, are there any end-to-end data protection mechanisms between the NVMe media and the application?
So you want to?
I can answer part of that.
Go ahead.
Right. So today I should point out that with NVMe as a NAND media, there's just very strong ECC and data correction and detection on the drives themselves. There are also CRCs in the protocols for InfiniBand. So we do have fairly strong protections. Yet on the client side today, we don't have that CRC checking. However, that is planned for our version coming out mid-year. So as far as the block storage itself goes, we plan to have a CRC that should be available for end-to-end protection if you want to turn that on by about mid-year.
All right, good. Thank you. Then I'm getting another one. That's probably for Brian. What were you using before you used NVMesh?
So there were two sets of solutions that we were using. One was a lot of Oracle RAC clusters and Unix-based solutions that were running on high-end storage arrays from different vendors. We also had some DSSD, which had its value, but as Josh mentioned, the controller at some point became an issue in the scale-out. It was more costly and had proprietary hardware, but that was kind of our first attempt to try to rid ourselves of the more costly and less adaptive higher storage array. And again, eventually we settled on the Excelero because we saw a solution that allowed us to drive pure commodity components on both, not only the rack side, but also on the storage side, and get that very small footprint, that form factor, and the ultra-high performance. So generally speaking, it was higher-end storage arrays, more costly solutions, Unix-based, with some Linux-based also. It's not really the server per se. The issue is the storage. So really the enabler for us to really reduce the cost, reduce the form factor, was the migration. We were on Linux platforms from our AAX. It was really the storage side. As Josh mentioned, it was our ability to be able to effectively, through the software, emulate and outperform traditional storage arrays. That really was the game changer for us.
Okay, good. And I'm getting more questions, guys, so I hope you have a few more minutes. One more question I'm getting is in comparison with 8 nodes and 3 nodes rack cluster, what was the CPU utilization? So the person who's asking this is assuming that fewer nodes will have a much higher CPU utilization, or does that person have it wrong here?
No, the fewer nodes. On the rack side, I think there are 2 points here. On the rack side, with the 8-node solution, we saw lower CPU utilization on those nodes. In fact, we saw a lot of excess CPU. And again, the reason for that was we can only drive so much I/O into that rack node. So what we ended up doing, and what a lot of people end up doing, is over capacitizing that client side because they need to get the I/O. So a lot of people out there in the industry right now have excess, I believe, rack nodes at lower utilization with higher licensing costs, just because they need another rack node to drive more I/O through to get, because Oracle, a lot of the Oracle use cases are I/O intensive. I mean, I/O is probably the most important, most limiting factor on large databases for Oracle. So the utilization was maybe typically in the 50% utilization, maybe 40%. On the Excelero rack client side, we're seeing that utilization go up to more 60–70%. So we still have, for a lot of our loads, we still have some CPU available on that rack node, but we're seeing a higher utilization because we're able to do more, run more queries, and drive more I/O into that node. So utilization has gone up with fewer rack nodes. On the storage side, as Josh mentioned, in fact, our solution right now, we're looking at the CPUs on the storage side, and we think we can reduce the cost of that storage side even more, but still maintain our bandwidth. So the storage side, very, very little I/O, CPU utilization on the storage side. On the rack node side, 8 nodes to 3 nodes, utilization has gone up, and better exploitation of those nodes.
All right, good. Thank you very much. That was very elaborate. And then I'm getting another question, whether this solution can be used for VMware vSAN.
This is Josh. No, at this time, we do not support VMware. So vSAN is just simply not a target. It's not, VMware is actually not very friendly to outside solutions such as this. So no, we're not supporting VMware today. Okay.
And then I have a last question here, and I think this one is for Brian. Did you ever consider to just use flash arrays with NVMe over Fabric?
We did. In fact, we did. We looked at emerging things that are coming out in Fiber Channel and NVMe over Fiber Channel. But again, we kind of wanted to rid ourselves of that storage array or monolithic investment and the kind of the architecture and the topology. So there's certainly some value in that, but for us, the ability to wrap the storage software solution around commodity hardware, that it makes it much easier to scale, much lower investment up front, gives us a lot more flexibility, reduced cost, and it's more of a pure solution. You know, we didn't want any legacy architectural components left as, you know, in our storage solution. And we feel with Excelero, we have rid ourselves of kind of the slow evolution from SCSI-based old storage array, flash, NVMe, and we've gotten to more of a pure architectural solution that can exploit the NVMe technology with the Excelero solution on commodity hardware. So we didn't want to move through that layer. We wanted to jump to an architecture that we thought was already positioned for the future and rid ourselves of some of the limitations that that solution presents.
Hey, Brian, that was great, and I'd like to give you the product side view on that as well. You know, the vendors that are just adding NVMe to their arrays, and/or then saying that they're going to add the NVMe over Fabric protocol. This is a smokescreen. I don't know, you know, how to call it anything else, but these kind of arrays are still centralized. The bottleneck is either the CPUs or the I/O architecture of that array. So adding NVMe media to an existing array is going to do almost nothing for the performance of that array. Just adding NVMe over Fabric protocol will reduce latency a bit, but it's not going to magically increase the bandwidth or the number of IOPS that those controllers are capable of. So the gains by adding NVMe over Fabric protocol to existing arrays, or to adding NVMe media to existing arrays, or doing both, is going to be extremely small. The gains are going to be almost non-existent. You really have to break the mold. You have to do something revolutionary to break that scalability issue, and we've done that with NVMesh.
All right, gentlemen, Brian, Josh, I would like to thank you for your contributions. I would also like to thank all of the attendees, and especially those with those interesting questions. I hope this was a good use of your time. If you think you know anyone who could have benefited from this, feel free to send the link afterwards to your friends and coworkers. Very happy to have you spread the news. With this, we're ending this webinar. Thank you very much, everybody. Have a great rest of your day, and we hope to welcome you on the next webinar sometime soon. Bye-bye.